So this is a TDS meter. You can measure total dissolved solid in water in parts per million, and this also has a temperature scale. This is generally used to measure the drinking water. So if the drinking water TDS is say around 10 to 20 or something like that, then the water will feel sweet, and that's very good. But anyway, here we are measuring what is the TDS of the distilled water. Just let me check. This is a commercial distilled water I am getting from the shop nearby. So let me check. So let me check with the TDS value. Actually I should measure the pH value, but right now I am not getting the pH meter, so I will just check the TDS. Of course, if it is pure distilled water, TDS also should be 0. So but yeah, it is a commercial distilled water, so we will dip, and you can see this is 0.005 parts per million. Okay, and of course the value is stable one, so it's exactly 0.005. so I'll show in my tap water how much is the TDS in Bhubaneswar. Pause. Okay, so I am marking on this glass to make sure that I add equal amount of water in every cell. That is why I am marking. So I am making 3 marks, which is needed later on. And yes, of course I am not doing it at lab, so I don't have any apparatus available at lab. So now I have to take this coin to remove the battery caps. So only you can use a coin to remove the battery cap, and of course the backup time has come down for this battery, and that's the reason why I suspected that there is a lesser amount of water, and of course I need to pour water. And again, what generally is checked is that the specific gravity, and for that you need a hydrometer. Again, hydrometer I don't have at home, so but now I have to open the caps. Okay, so let me pour water one after another. I am expecting that this much water will be needed in each cell, so it's only approximation. So what I do is that I add a similar quantity of water in every cell. I have poured around 2 times 60 ml water in each cell, and you can see that still the water level is down, so we have to add even more water. So I will add 120 ml, that is 60 ml each cell, one more time. Okay, so you can see that the water level is quite visible now in every cell. It's quite near now, so it's in every cell it is quite near, so that's enough of water is given. And especially you can see that towards the positive terminal, okay, it was more of a dry. So the cells towards the positive terminal was dry, and of course in these caps there is a hole. Every cap you can see there is a hole, and this because of this hole the bubbles can come out. So the hydrogen gas bubbles come out of this hole, and that is the reason why every lead acid battery will have a hole on the cap. Okay, so that once the reaction is going on, see right now if I check, okay, so let it charge for 8 hours, and after 8 hours of charging I will record the video again to check what is the terminal voltage. And because through these lines, you can see through these lines the charging is happening, so therefore if I point the charger here, it will read around 14 volt. Okay, so it should be around 13.6 to 13.8 volt. But whereas the battery terminals means like this, you can see this lead caps. On these lead caps if I touch, then I will see the actual voltage. Right now I have poured water. If I check the voltage, it will be around 6 to 7 volt. Okay, but after charging for around 8 to 10 hours, once the full charging has happened, so that time we can see that again the battery voltage is coming to somewhat 12.5 to 12.6 volt, and this is again an old battery, so that's why it will not go up to 13.2 or 13.4 volt. But of course in new battery it would have been gone to 13.4 to 13.2 volt, at least 13.2 volt. Okay, but because it is old, it will go up to say 12.6 or 12.8 volt. That will check tomorrow. Okay, thank you.